is being mentioned. Welcome everyone. A very good evening. We'll be starting in a few minutes. Let's wait for everyone to join until then. Very good evening. Welcome everyone. Thank you for joining. So before we start, let's get to know each other a little bit. Please drop in the comment section where are you from, where are you joining from, so that we can get to know who all are there and from all over India, from where people are joining us. cool. So now that we see a few people have joined in, we'll start on with the webinar. So first I'll introduce myself. I'm Vishakha from Rebase by Recro, and I'll be hosting this session today along with our speaker, who is Kirti, who is a software engineer at Recro. So today's webinar is on understanding concurrent rendering. So for those who haven't heard enough about Rebase, I'll quickly take you through. So Rebase is a developer community of 2,500 plus developers growing and learning together every day. We have grown so much at this rate within a year, and it's mainly due to the support and backing of our amazing members and especially our mentors. We are striving to build India's best developer community for you guys. So about our mentors. So our mentors are highly experienced developers from tech giants such as Google, Uber, and Microsoft. This is a small snippet from our meetups. So we keep on having these networking meetups from developers, for developers from all over India, so that you can grow your network with fellow Rebase members online and offline. So who is Rebase for? If you are someone who is looking for a community to learn from, want to get connected with like-minded people, network, get mentored, find job opportunities, please feel free to be a part of our server. It's absolutely free, and this is an exclusive community. So the experience should be good for all of you. I'll be very soon sharing the chat, the link that with which you can join the community. So now I'll introduce you to our guest today, Kirti, who is a senior software engineer at Recro, as I mentioned earlier. So today's session is actually a continuation of the webinar that we had last month on React 18, concurrent rendering, which was an amazing session, and we had amazing feedback. So that is why we wanted to have Kirti with us again here. Since the topic is so vast, Kirti is super kind to give us another session and go more in depth with you guys. I'm sure this session is going to be super useful for your web development and to get past all those rendering delays. So say hi to Kirti, and she is a very special part at Recro. She has 5 years of experience as a software developer, loves designing and building digital experiences. She believes in keeping things simple for the best user experience, and has also been a speaker at React India Goa 2023. So we are thrilled to have you, Kirti, today with us. So before we start with the learning, just a few announcements. This event is brought to you by Rebase by Recro, which again is a developer community having 2,500 plus developers on Discord, learning and growing together. So I'll be dropping the link in the chat box, so you can join the community from there. Towards the end of the session, we'll be having a Q&A session. So guys, please, if you have any questions, any doubts, anything you want to ask Kirti, you can drop it in the chat box. We'll be taking them at the end, and we might also pick a few during the session. Over to you, Kirti.
I'm requesting share access. Can you please provide me
Now I can
share screen access? Yeah.
Are you able to share it?
Yes. So please confirm, Vishaka, if you're able to see my screen.
Yes, I can see your screen, Kirti.
Okay, cool. Yeah, so hi everyone, and thank you, Vishaka, for such a warm introduction. And thank you to Recro for giving me this platform to, share my ideas and reach out to more people. So let's begin. Today's session is actually a continuation of last session, as Vishaka already mentioned. So this is going to be a little bit more in-depth, or like what do you say, more about the core internals workings of React Scheduler. So it's important that you actually understand the first session, whatever we covered the first session, although I'll try to give you a brief summary of whatever we have covered in the last session. But if you were not part of the last session, I would request you to go and check the video out. It's on Recro's YouTube channel. So in this session, what we'll cover is how actually React Scheduler prioritizes state updates, and what happens in the browser when you run start transition. So, and also how to use start transitions or your use transition and use the deferred value hooks that React introduced in its version 18. So these are actually targeted at helping you with making the browser more responsive and reducing the time it stays frozen. That is the total blocking time, which is a web metric. So why do we need concurrent rendering? All these, so whatever I'm going to cover right now in the next 5-10 minutes is actually discussed in more detail in the previous session. This is just a run through of, whatever was covered so that you don't feel like you have not heard these concepts only. So in the previous session, we covered why we need concurrent rendering, and that's mostly to avoid having running into long tasks. So any task which is more than 50 milliseconds or takes more than 50 milliseconds is considered to be a long task. And because we are dealing with huge data and complex applications lately, it's easy that it's very much a given that we will end up running some long task every now and then. So how does React help with concurrent React help with taking down these wrong tasks is what is the main USP of React 18. Next, we have covered how actually rendering works under the hood. So we have covered that every visual update happens in two phases, that is the render phase and commit phase. And render phase is usually, where all the rendering or your computations happen, where your existing virtual DOM is compared with, what it's actually the diffing that takes place wherein you are creating a new tree of React elements, which is also known as the virtual DOM, and you go on marking if a component is dirty or not. And if it is marked dirty, that means it has to be updated in the next render. So that is done as part of your render phase. And once your rendering of all the components is complete, you commit, the updated virtual DOM to your browser. That is where your actual DOM lies. So Also, we then, discussed about the fiber loop. React has uses the fiber reconciler, which was introduced in React 16. And it actually had this capacity to, support concurrent or your async rendering back then, but it did not actually have any APIs to expose to the developers to take advantage of concurrent rendering. So the fiber reconciler is also crucial in understanding your how concurrent rendering works, because it your divides your state updates into units of work called fibers, and every time a state update happens, again every task is assigned a certain priority, or uh, and based on that they are passed to the work loop and they are worked upon. So it's important that you just understand the work loop, begin work, complete work functions. We also actually have seen them by running brief overview of React internals, how a state update triggers and how that updates are scheduled and then they get rendered, and what what functions run when actually, and how we have actually discussed all of this by running an example in the browser. So yeah, please do check that out. Next, we have discussed about blocking render versus concurrent render. So blocking render is when the rendering is, a single uninterrupted synchronous transaction. And once it has started, it cannot be interrupted. So once you start a render, it has to complete. There's no interruptions in the render. And that's why most often what happens is, if you don't use any optimization on top of your basic React, it can end up being blocking your user interactions during a particular render. So regarding that, we had actually seen an example also wherein we were trying to actually type something in the search bar, and it was taking some time before actually showing the result in the inputs. So if you see here, I typed LUX, and it's taking some time before even LUX, the letters are seen in the search box. The list is getting filtered and that is taking 1 or 2 seconds, that is fine. But even to be updated in the input box, it is taking like actually 1 or 2 seconds, you know. So this is because the updation of the input field value as well as the list filtering is given same priorities. They are, in blocking render, that is in versions before React 18, this is how it would work. All the tasks or all the updates would be given same priority, and that's why there was no possibility to differentiate it. And that's why we could see this UI that's a little sluggish and slow, and a user is not seeing real-time updates of the inputs that they are giving. So next comes concurrent rendering, which was introduced in React 18. So in concurrent rendering, it's that there is still a single thread that's working, but right now the rendering is interruptible. So it's possible that you can interrupt, pause, resume, or even abandon a render. And this allows user to react to, respond to user interactions quickly, even in the middle of a heavy rendering task. So we took an example of a simple e-commerce page and discussed about how blocking render will cause a delay of 100 milliseconds before the user interaction is actually acknowledged by the browser. And concurrent rendering almost handles it, immediately. So next, we also saw how concurrency is working in React. As I said, there's a single interruptible thread, and because the rendering is interruptible, we can handle other main thread events like network user input or animations, other network events along with that. So the main concept here is that concurrent React does not block the main thread. It improves the responsiveness of the application. But the caveat here is that it does not actually lessen the time of execution of long tasks. Long tasks will take whatever time they were intended to take. It's not going to lessen that, but it's just going to make your browser more responsive because to user interaction, so that users don't feel that the UI is stuck. But actually there's no lowering. It's not like your tasks are performed faster with concurrent React. That is not the case. It's just that your rendering is interruptible. Now remember that rendering and updating the DOM are two different things. So rendering is actually, as we discussed, the computational phase wherein React is reconciling and finding what are the changes to be done in the next update, UI update, and that is what is interruptible, not when your React is committing all the changes, that is the updated virtual DOM or the updated fiber tree. When it is updating to the DOM, that is actually one synchronous transaction only. That cannot be interrupted. So rendering is just about the computations wherein, React is, the reconciliation is actually interruptible. So like the basic idea is, to while rendering the next view, it's keeping the current view responsive to user interactions. So that's about it. So we also saw that now with concurrent React, if there is a low priority task, it's actually the rendering of that update is happening in chunks of 5 milliseconds. And because of that, your browser will return, the React will return control to your browser every 5 milliseconds. And that's why it can acknowledge whenever your user interaction occurs. And every user interaction is considered to be a high priority update, and that's why it is immediately handled. That is, your rendering and committing that update will happen in one synchronous transaction. So if we look at the UI of just now that we had seen, the input field, whatever we are typing into the input field, it has to be reflected immediately. Only then users can get a real-time experience, okay, that they are interacting with your UI. Otherwise, it feels sluggish, slow, and non-responsive. And that's why every user interaction has to be considered as a high priority update. And it will be handled almost immediately. And once that is done, your the pending low priority update will be taken up again, resumed again, and completed. So how does your, browser keep your React keep your browser interactive in this sense? So in concurrent mode, tasks with higher priorities could interrupt tasks with lower priorities. That was the idea when developing this functionality. And we need a way to interrupt the tasks and resume. So the team actually worked around having a scheduler package in React that takes care of scheduling, prioritizing, and deferring updates. So the scheduler's primary responsibility is to manage updating pushing these tasks based on their priorities. And the priority actually determines which task will be, which task will start, when they have to pause or resume based on the priority of the task, and also what is the priority of work that is already happening in the queue. So it utilizes a cooperative multitasking model, which means that it allows multiple tasks to execute concurrently. This model is made possible by breaking, the work into smaller chunks called fibers. So we just like React has a fiber reconciler which actually breaks down all your updates and tasks into smaller units of work. So every component is having a fiber node associated with it. We briefly discussed the fiber node data structure also in the previous session. So if you want to check that out, please do. And because of this, because we can perform these updates in smaller chunks or, units of works called fibers, they can be, incrementally processed. So in a cooperative scheduler, what the React team, says is that we can't forcibly interrupt rendering whenever we want in a way that, your operating system scheduler can suspend a process. But it's possible for us to, yield control back to the browser every in between your React component updates. So since most individual components don't take a single frame, more than a single frame to render, that's enough granularity is what the React team has to say. And that's also the current heuristic that they have followed. So what the React team follows when it comes to concurrent rendering is that the execution is yielded back to your browser. That is, control is given back to your browser. There's a web API for that, which is, I think, request host callback. That is the web API that the browser provides. And your every 5 milliseconds, you are requesting you're giving back the control to your browser so that it can handle events. And this is not like a magic number. If you see that it is 5 milliseconds is smaller than a single frame in 120 FPS device. So even if we have to consider animations, it won't block them. And that's why this is the current heuristic that is followed when it comes to concurrent rendering by React team. So the scheduler assigns your task certain priorities, and there are 3 levels of priority. Actually, there is scheduler priority, event priority, and lane priorities. All this was again covered previously, and let's not move spend much time there. So your render lanes also are, render lane is just something, just another way of assigning your priorities to your tasks, or it makes your prioritization more granular, we can say. It is nothing but, a lane is nothing but a bit mask. It's a 32-bit integer, and every lane has just one bit marked as 1 in that. That's it. So that makes it like, there are 31 lanes, and some lanes are like, assigned higher priorities. Like your sync lane is for tasks that have to be performed synchronously. Then there is selective hydration lane for, selective hydration feature that came again was released as part of your React 18. Then there is default hydration lane, which is for hydration. And then there are transitions lanes, which we will discuss in some time. So again, React has actually kind of 3 queues. What you have to understand right now is that there's a update queue, which is actually holding all your updates. So every time an update is actually called out, or a set state is called out, there's an update that is passed to your update queue, and your update queue will have all those updates. But do remember that it's not necessary that every time an update is scheduled, it is handled right away. So there is a different queue for your updates, and there's a different queue for your tasks. So once your update is actually scheduled, or by your scheduler, only then the corresponding task for the update will actually be pushed to your task queue, and will be taken up by your fiber reconciler when it actually times out. So let's take a look at that. Just a second, my screen seems to be stuck. Vishaka, is my screen moving back and forth?
Just a second, Kirti.
Yeah.
Yeah.
So we discussed that the fiber tree, right? So there is actually two virtual DOMs, or you can say that there are two fiber trees. Virtual DOM is nothing but a fiber tree, which is a lightweight representation of your DOM. These are just two different terms. If you speak based on the data structure wise that React follows, it's actually the fiber tree. But if you speak in terms of understanding more closer to your browser, wording, it's virtual DOM. So the fibers actually come in pairs. There's a current fiber tree, or which is your current virtual DOM, and there's a work in progress fiber tree, which is which will be your updated fiber virtual DOM, and that has to be actually mapped to your or committed to your DOM in the next update. So every time you update is actually scheduled, what happens is Fiber Reconciler goes on comparing each component or each fiber node, you can say, and if there is an update pending on that node, it will mark or flag it as dirty, which means it has to be updated. The DOM has to update it for that node in the next, commit phase. So that's why it goes on marking the fiber nodes as empty, and that is what is your, work loop doing. We have seen that work loop has a begin work and a complete work function. So begin work, you go down tracing the fiber tree and marking every update, every component which requires an update as dirty. And, in your commit phase, you go on committing those changes to your DOM. So now let's actually understand the fiber scheduler here in a little bit more detail. So whenever an update is scheduled, your this function called schedule update on fiber is actually called, that will take a fiber route, and it has a lane assigned to it. So in this you've seen that if you consider an update, every update is actually assigned a lane, and that actually decides the priority of it. So when your update schedule update function is called, it actually calls your ensure route is scheduled function, which makes sure that a re-render is scheduled for all the pending updates. Still, the updates are not yet processed at this point, since actual re-render has not yet started. The actual start of the re-render depends on few factors like category of events, then the status of scheduler, again lanes. If we use something like transitions to defer an update, it will actually be deferred until a timeout is complete for that. Next, so this function actually schedules a task for a fiber node to do the updates if there are any. And there's only one task that is assigned per route. If the task was already scheduled, in a previous render pass, then we'll check to make sure the priority of the existing task is the same as the priority of the next level the root has worked on. This function is called on every update and right before actually exiting a task also. So if you see in this function, we are actually, determining the priority, scheduler priority based on your lane's priority and your event priority. So it's not like your lane priority, your event priority. By event priority, I mean user events. So whenever you're clicking something or you're typing something, that is given discrete event priority, which is like the highest priority. It has to be handled immediately. So that is actually, those priorities are actually decided in this function and assigned to your root, fiber root. So next, this function actually schedules a callback then. So once your updates are assigned, the specific priorities, it will actually schedule a callback and push to your, callback queue. And then actually, so this is schedule callback is actually the API exposed by your scheduler to schedule task. And this is actually used by your React Fiber work loop to schedule tasks. And then comes your perform concurrent work on root. It returns a closure if interrupted. So we can see that based on the progress, it returns different things. So in again, perform concurrent work on root, we'll see if there is any blocking lane or if it is an expired lane, and based on that, if it will decide if it should time slice or not. Time in the sense whether it should render concurrently or it should render synchronously. So if it is not the case, and if it is like a synchronous update or a high priority update, it will render it synchronously. When in your work in fiber loop is going to work on it immediately and push all the changes. But when it comes to your low priority updates, it actually renders them concurrently, in the sense that if you see this work loop concurrent function, it will check if it should yield to host. So this should yield to host is actually calculating every 5 milliseconds if the the work is done, or if not, if work in progress is not equal to null, and it's like you need to give back control to the browser, then you give back control to the browser, and you schedule the route as not, or the work on that route is to be not complete, and a callback is returned. But if the work is like, you need not schedule to, because if it's just not been 5 milliseconds, then you continue working and then again process it. So the work loop concurrent will actually break if your should yield function returns true, and it'll then be your work on that fiber root tree will be incomplete and another callback will be scheduled. I mean, the same callback will be scheduled to be resumed, not another one. It's just the same one. So what actually the scheduler does is it looks for the return value of this callback to see if there is, a continuation. If the return value is actually used to decide whether we need to reschedule these tasks or not. And this is how your interrupter of nature is decided. If it has to be rescheduled, that means it has been interrupted because it is necessary for you to give control back to your browser. And if not, you continue with your rendering process. Now, if you see your schedule callback is actually a function that will take your priority and the callback, which has to be triggered once this task is pushed to your task queue. So this callback will actually, for each priority, we have seen that for each priority, we have different timeouts. So timeout is nothing but your start time and the timeouts that we have discussed here. So your immediate priority will time out almost immediately. Low priority tasks will have a timeout of 10 seconds. Normal priority tasks have a timeout of 5 seconds. So every callback for an update that is scheduled will have a priority level and will have a timeout. So expiration time is the start time plus timeout. And as soon as this expires, that means it has to be scheduled. So this is actually checks if this is a delayed task. In which case will it be a delayed task? If we mark it as a transition, then that will be a delayed task. And in that case, you will wait for the timeout. But if it is not the task, then it is pushed to your task queue immediately. And then this request host callback function is actually the function, which will give, will actually decide if you have to render concurrently or not. So in order for the in order for the scheduler to schedule tasks, we need to store tasks with your priorities being tagged. And this is actually done by your priority queue or the task queue. So it uses the expiration time to indicate priority. And if it expires soon, as sooner as it expired, the sooner it will be processed. Then actually request host callback will flush work, which is nothing but it's calling your work loop. Again, a work loop is very similar to the work loop concurrent that we have discussed in your fiber reconciler. Work loop sync and work loop concurrent. The task of it is again the same. It will see if it has to yield to the host or not, and schedule callbacks almost likewise. So what they do is this work loop is actually the core of your scheduler. And what it does is as I said, it will see if your 5 milliseconds time has elapsed. If yes, it will yield control back to the user. Else it will, check if there's a pending paint or user click or event has occurred. If that is the case, also in that it yields back control to the browser. And so under the hood, how it works is actually there are two web APIs called performance.now and is input pending. And this is actually used to check how long your rendering takes. If rendering takes more than 5 to 50 milliseconds, then it is actually your yielding back to your browser, or if is input pending is true. And is input pending is true when user is actually interacting. So in that case, the web API returns true. So in these two cases, it's like React pauses rendering and yields back to the browser, so that your browser responsive nature of the browser is intact. So this was actually, you need not know the complete understanding of how the scheduler package works, but to implement use transition or use deferred value. But knowing that, okay, there is how your fiber reconciler works, how it utilizes scheduler to schedule tasks, and based on your priority of the tasks and timeouts, how it is actually flushing out and flushing out work that is nothing but updates, is kind of helps you to get a better understanding on in which case you should actually be using transitions or in which case you need not be. And honestly speaking, so or using all this, as again, as I said, right, it does not lessen the time that your update is taking. It does not really lessen the time uh, any complex task is taking. It's just keeping your browser UI more responsive and interactive, so that the user does not get a slow experience even on slow devices. They don't feel it is non-responsive. So on fast devices, long tasks will obviously, won't take much time. And even if it is lag, it is fraction of seconds. But this is more important when it comes to your application is used on more slower network ranges or on older devices that tend to be more slow. Now let's actually see how this looks in your browser. So let me just refresh. So in your browser, if you okay, so I refreshed and my profiler is running, and I'll just type plastic. So you saw that in a blocking render, even for the PLAS, that string to appear on the input box, it took some time. And if you see this profiler screen, just give me. Yeah, so if you see a profiler screen, we have discussed all these flush work loop, perform work loop, concurrent. This is actually how it's called. And then you see that your list component, right? This is a list component that is actually being called in one single render. So you see, this is a huge long task that's actually taking 500 milliseconds. Uh, and this list is actually rendered in one synchronous go. And when we made an interaction, that is when we typed the string, it actually re-rendered it again. And that too synchronously. Okay, now this is something that you understand first, because when you'll get it more clearly when we see how concurrent rendering is actually happening, or how use transition is actually making a difference in this case. So this, again, the list render here is one synchronous change, as you see. And so next, let's understand what are, transitions and how actually they help us. So a transition is nothing but, a concept React uses to distinguish between urgent and non-urgent updates. Transition lets you keep the user interface responsive even on slow devices. So with so your urgent updates have are like, reflect direct interactions, like typing, clicking, pressing on the screen, or like, mouse over, all these. So this actually, if you have some sliders on your screen and you're doing a mouse interaction, then that has to be immediately updated. So all your urgent updates are like, updates that need are real time, that they have to be giving visual feedback immediately. And your transition updates can be anything that your UI can, transition from one view to another. So it need not be immediately real time, but it's usually response to some interactions, and then the update is actually happening. So it's something like list updates, or your animations or something like that can be a transition. So the thing with why it is important to distinguish between these is, like, if you see typing, clicking, or pressing, these are like uh, real-time interactions, and if they don't, if you or UI is not giving immediate feedback, they sort of feel wrong and lead to a, bad user experience, because user feels that your app is stuck or not responding only. So that is not good if your users are not getting a real-time experience with these updates on your application. So startTransition is the API that actually handles marking an update as non-urgent or as a transition. So let's just go for seeing how it's actually implemented. So your updates wrapped inside your startTransition are handled as non-urgent and will be interrupted, if more urgent changes like clicks or key presses come in. So if a transition gets interrupted by the user, the React will throw the stale rendering work that wasn't finished, and it will render on the latest update. So there are two hooks that are actually exposed by React. One is the use transition hook, and other is the use deferred value hook. In case you're not using function components, you can use startTransition by itself. So you can just import startTransition from React and start using it in your class components, because function components can be, again, only used inside hooks can only be used inside your function components. So this is actually the transitions of startTransition, use transition hook, all these actually is like gives you an opt-in to concurrent rendering. That means you have to actually explicitly add them, only then you will be able to take advantage of the concurrent rendering features. If you're not using startTransition, use transitions, and putting your state updates inside these, then your state updates will, even in React 18, they will behave as in React 17 only. So it's asynchronous. If you're not using explicitly use transitions, these updates are your synchronous updates only. So you see that use transition actually returns an array with two items, that is pending, which is just a flag that will tell you if a concurrent render is in progress, and your startTransition function. So what startTransition takes actually a function inside of it, and we usually write your state updates that you have to do inside, which are your low priority updates inside that. So what this indicates is this update, your set filter can happen as a transition, and it can be interrupted in case any high priority update, or the rendering for that state value can be interrupted if at all any high priority update comes in. So now let's look. So what we have done is, again, it's the same example wherein we are having a field for the search query, and then we are setting a filter. In your blocking app, what we had seen is that there is just one state component, that is your search query, and it is you also used as a filter for your list component. But right now, what we'll do in our demo of use transition is that we'll use a filter, and which again will have the query that is entered only, but it's marked as a transition. So that means this filter value will be updated in the background, and it will not block your search query or the HTML element or the component that has to be rendered based on this value. So what we see now is that If I try type plastic now, it's real time. That is, PLA is seen immediately updating, and then with a lag of some fraction of seconds, your list is getting updated. Let's check out the profiler also for this. So once again, let me show you. I'm typing tasty. So no results found for this one. Tasty. Yep. Again, if I go for towels, maybe TOW is again immediately seen, and your list is updating with a little bit of lag. So this is actually a low priority update, and that's why your list is not blocking, the render of the list is not blocking this input query that is being entered. Now, if we have to check this in the profile, let me run the profiler. If you have to check it in the profiler, there'll be one, initial render task. And if you see here, there are two renders. Okay. So this is your initial render for mounting. And then you have your interactions. And you have another render. No, it's here. You have your keyboard interactions here. And that is actually causing your another render. Now, if you see here, your list is actually not getting, rendered in one single task. Here, it's actually getting rendered in chunks. So this is actually your list component, your sleep function I have added inside your list component. So this, if you can see in the profiler right now, it's actually being rendered in chunks and in between them, the control is given back to the browser. And that's why if I again re-upload is, what I'm doing is I'm typing TAS and then I'm typing TY. So you see, now there has to be again two rendered. One was for TAS and another for tasty. And that too, in that case also, all your list component is actually rendered in interruptible manner. So if you see, the list component wasn't completely rendered yet, but still I could type. And this is actually out of the box. Earlier, what if we had to simulate similar kind of behavior, we would have to use something like debounce and throttle. So we would have to actually delay your, uh, function call for some time, so that your filtering is only done after maybe the user has entered 3-4 letters. Otherwise, if you did not add the bounce and throttle, the list would run on like when I type every component. So your input handler function would run on like every time. But right now, it's just running with concurrent render. It's only running, or your list component is only rendered when the browser is in its idle cycle. That is, if it has the input high priority update is actually complete. So I type something like LUX, I see it, it's complete, and then your list is updated. Now I can actually turn on your CPU throttling to show this to you. So let's go for a slow 3G. And let's see how this works. TAS again, I see almost immediately, and then your list is updated. Now, one more question here that you may have is that it's the function inside start transition that you're passing. It actually needs to be a synchronous function. And it's not like this, the function that you pass inside, start transition that will be scheduled for later. So this callback function that you pass inside start transition, this itself will not be scheduled for later. This is running actually almost immediately only. It's just that the state update that this transition is causing, that is set filter, that gets scheduled for later. So transition lanes, as we've seen, there are like 16 transition lanes, and based on how many deferred updates are in your queue, the next update will be assigned one of these lanes. And so this particular, it takes lower priority basically. So this means that if one transition lane is having one priority, and based on that your timeout is something like 5 milliseconds or 10 milliseconds, that will get scheduled for 10 milliseconds later. So it's what it means here is only a set filter. This update will get scheduled for 10 or 5 seconds later, and not actually this entire function is not actually running late asynchronously. So it is not like a set timeout. It's just that this update is getting scheduled for later. And if I have to show you that, I can actually add console logs, which will kind of then maybe add one here, add one here. Just wait a second. So this should actually show ABC. That's right. Adding it in the right component. Okay, this is on handle input changed. So let me add some input, and you see that I've got ABC, ABC, ABC 4 times, which means that this is actually executing at that time only. It's just that the state update is scheduled for later. And one more thing to notice is that so if React has started rendering, the result, like suppose I enter tasty again, TAS, a split second of time, and then tasty, TY. So what I did is I typed TAS, just a split second of pause, and then TY. But it did not show me the result for TAS only first and then tasty. So TAS, if you see, it does have different result. It's not like TAS and TSTY is the same. It does have different result. But when I entered it with a split second of gap, it did not show me a different list. It showed me the list or filter for tasty only. So how does this happen, or why does this happen? This is because if React starts rendering the first results it was working on, and then it would start to build up a queue of results to render, which would take some time. So instead of just rendering like whatever it's going on, but your input state is updated. instead of continuing with that, what React does is it actually abandons the previous render. So we have seen that a render is interruptible. You can pause it, you can resume it, and you can even abandon it. So while a current render is going on, but the value that is utilized for that render is actually stale. And at the moment it has updated, React will utilize the latest state value only to continue with the render if it is a low priority update. So this is also something that is very unique about use transition. With debounce and throttle, that is not the case. With debounce and throttle, what would happen is after the set timeout is over, your delay is completed, it will definitely what is it, run the function or callback for sure. So if the callback involves calling your APIs, then it will place like two requests. In this case, with the filter, is that the user does not see two different filters for a split second of gap, because the UI state gets updated. The previous render is actually abandoned, and React considers only the latest state value and gives you the result for that. So this is also something very interesting about use transition. So that means that React is only working on the UI that the user will actually need to see rendered, and not, the old state. It does not actually preserve that. So last section is like for use deferred value. So use deferred value is actually used to defer an update. So it's you advised to use deferred value for controlled updates most often. And also if we have uh, components wherein we are like, for this example, actually, if we have parent component, child component, like a parent child tree, and your parent component state update only controls your child component. In that case, you don't have access to your set state function, and that's why you cannot use transition and then wrap your set state function inside of start transition. So what you can do in that case is use deferred value, so that you can take the prop that is passed by your parent component and defer its update. So whenever your parent updates, the child component need not you can to have some performance optimization, or to have some control over that, your child component can use this hook to delay updating that component based on your parent's state. And also for controlled components, it's advised to not use transitions and to use deferred value itself. So this function actually returns, just takes your say value that you want to be deferred, and returns a deferred value for the same. So this can be what it does means is, during updates, the deferred value, in this case, in our example, the deferred search query will actually lag behind the value of search query. So React will not update the deferred search query almost immediately, but it will do so in the background. So that means that even your value, that deferred search query value, is updated in an interruptible fashion. So what we see here is, if I have to use or show you that this one now, let's just change deferred value. Okay. So it's again the same function, no change as such, just that instead of passing search query to your filter, we are passing the deferred search query to the filter. And let's see how this acts. Potatoes and Now, this is also kind of similar for this example, is that if I again type TAS split second and then tasty, it will not show me the update for your TAS. It will rather show me the update for the complete string. So this also helps because your deferred query value is not updated by that with similarly to your search query value. Let me just, console log it to show you, and that will be more clear. So you see, this is your search query value as your input field only. It is getting updated T, TA, TAS, TST, Y. But your deferred query, let me actually put some string to differentiate in there. Okay. So first value is actually a search query and the second value is your deferred search query. So you see, your search query is getting updated, but your deferred search query, so in the initial pass, it will be same as the value that is entered, but when it is updating, it will lag behind your initial state value. And it will just take, so when your initial state value is actually completed updating, only then, because this is again the same concept, high priority and low priority update. Your deferred query update is a low priority one, so it will only be processed once your high priority, that is your input field update, is done. So in this case, search query is like high priority. Once it is complete, only then your deferred query is getting updated, and that's why you get the complete value. So this is also, if you see, like very similar to debounce and throttle, but it has one advantage, is that you do not have to specify any fixed time delay in this case. And it's not like it's run I mean, after the time delay is done, it is run, or it is taking into consideration the old value. That is not the case. Once your scheduler or is free to push the updates, it considers only the latest value and pushes your update. So that's why your list will not get updated with any intermediate values that are updating once, when the user is still typing into the screen. It will just take the final value and show your list component, which is again a very good advantage and optimization. So, but do remember that use deferred value. This hook, the value that you pass to this hook should be like primitive value or objects created outside of rendering. So if you create a new object during rendering and immediately pass that to use deferred value, it will be different on every render. And it will also cause your unnecessary background re-renders as well. So the value that you're passing to this use deferred value should be outside of your, any uh, values created, not intermediate values created during rendering. Also, one more thing is that again, I've covered that it's mostly advantageous if you use for, control components, and it's again a very good alternative to debounce and throttle. So, and also let's look the profiler for the same thing. Let's see how that looks. It did not capture, is it? This is the initial rendering. See, if you see here, the keyboard interactions, there are not like separate keyboard interactions. It's considering it as one single go. And that's why there are just two render passes. Obviously, the first render pass, because for your even your what is that? When we are entering, there is one render pass happening for the initial time your search query is updated, and that's why your list does get rendered once and second times. But you see in the intermediary, it is not actually, there's no render call that is happening. So this actually helps you in, giving a more control to the users, and avoid the slowness or sluggishness that they witness during long rendering takes. So I think the goal of concurrent React was mostly to avoid this thing of having, non-responsive UI because of long rendering passes. And that's why they have concurrent rendering is such a beautiful feature that has, exposed a lot of benefits in React 18. And also there'll be more, interesting things to look up to coming in the next versions of React. So this can actually help us a lot with animations as well. It's just that React team is still working on it, and there are a lot of interesting features that will be coming ahead. So I think that's all what I had to cover in this session. But before closing, I'll just tell you that, see, it's not necessary that these are, features that help you with responsiveness, but they are not necessary to be used in every use case. So it's actually a little computationally intense. And if you see, it's actually your long tasks are, because they are even low priority updates are interrupted most often. It's actually taking longer time to complete than your initial, without these transitions, or without these hooks, or without any concurrent features. So only use them very judiciously, and also go through your documentation to understand what are the caveats involved, and then only go ahead and implement it. So I think that's all from my side. Thank you. Yeah, but I think we can take some questions, Vishaka.
Sure. Kirti, I'll be dropping the questions in the chat box here in Zoom for you. Request you to just read it for our listeners once.
It's a chat of Zoom.
Yes.
Okay. I see only one message there. That's it.
Yeah, these are two questions.
Okay.
Yeah.
So scope of React and Fury compared to so do you mean scope of React in future compared to other technology? I think, yeah, I think that's what you meant. So scope of React, it's actually, React is still relevant. And again, if you see the previous versions or releases that have been happening for React 16 introduced such great features. The fiber reconciler, previously they were using the stack reconciler, then they completely shifted that data structure only to a fiber node data structure, which is based on linked list, and it's turning out to be so beautiful, and helping us with so many optimizations and so many features. hooks were introduced. They are accommodating concurrent rendering now. They are trying to do many changes to suspense. Again, if you see, after a while, React is great, by the way. If you want to get started with front-end development, do start with React. It's amazing to learn as a technology, but it's like, I think any software engineer cannot just stick to the idea of having expertise in one technology. It's great if you have, a crazy expertise in one technology, if you can, uh, understand React in depth. Again, Fiber Reconciler, even these topics that we covered today, how scheduler works, this is in depth only. If any developer has to develop any application right now using React, they don't have to understand how all of this works. They only have to understand all the APIs React exposes and the framework and the usage around the framework. They don't actually have to know how React is helping with the optimizations it is known for. But having said that, after a while, you should not rely on your expertise in technology, but more on your expertise on how actually things work, how actually front-end applications work, how your browser works, and why certain frameworks employ certain optimizations, and how performance can be improved. Understanding it from a user endpoint and browser tech perspective, that is understanding it in terms of system design wise. So lately front-end system design wasn't that popular previously, but only I think the DB and backend system designs were like very much popular or talked about. But lately, with the advance of front-end technologies, people are talking about front-end from a system design and architecture point of view. There are front-end discussions around front-end architecture also that they are discussed. So I think after a point, it's more about understanding how you can use the technology that is exposed to you to and how effectively and how efficiently you can use them to benefit your applications. So yeah, I think invest a good amount of time to gain your expertise in JavaScript and any of its framework. React is great to start with, but after that, you have to understand other things like your browser architectures in detail, then your application front-end architectures, maybe design systems and UI components, component structure, understanding what are the optimal ways you can structure them, understanding Webpack, module, bundlers, all of this. So that I hope answers your question. Next is, now that new features have been released, how long do you think it will take for the rest of the companies and startups to use and catch up to React 18? I see many code bases now switching to functional components. So I wanted to know if learning these new features helps in the long run. Definitely, I think you cannot miss out on staying updated when it comes to any framework or technology. Like technology is something that evolves at fastest, I feel, and you have to keep up, because what React was used 3-4 years ago, it's completely different way. The developers, how they were using 3-4 years ago is completely different than how they are using React now. So React 18 also is not adopted by a lot of companies now because it's still very new, and a lot of production code bases are using React 16 or 17 still, and that's okay. It's not required that every new feature, because it is fancy, you jump into using it. That's not required at all. But having said that, as and how the frameworks evolve, suppose I was starting with React like maybe 4 years ago, then I would not have used hooks for sure. I would have used only class-based components. But then if that same code base is still running for 3-4 years and has to be made some changes, then obviously the React 17 or later that has been introduced is giving you more benefits and does have, better advantages to, switching to functional components or hook space architecture. Not just based in terms of performance, but also there comes a point wherein, the resource, uh, how well equipped your resources are. So if you see companies now prefer the companies, if they're hiring freshers, they do not know how class components work. Mostly they are so used to just using your functional components and developing everything with functional components and hooks, that if they are working on legacy React application, they take a while to understand how that works. So it's like, as in how you progress into the future, there are certain advantages that you have to take into consideration and switch to them. But if it's not required, again, don't. It very much depends. Every application's use case and requirements are different. They need not have to adopt all the new features as and when they come. But eventually, it's like your code bases do shift over time. So, and that's why staying updated as a developer in all the latest releases of your core technology is pretty important. Yeah, I think, do we have any more questions, Vishaka?
No, I think that's all, Kirti, and I think we are way past our time.
Yep.
So I think we should conclude the session. Um, so yes, thank you everyone for joining. Thank you, Kirti, for giving us another insightful session. Um, you're on mute.
Vishaka, I'm really sorry. If you just don't mind, I think there are 3 more questions in the Q&A section. Can I just address them quickly as well, if you
Yeah,
don't?
sure.
Okay. What's my take on React Forget compiler, which they talked about in the React India conference? I spoke to Satya Gunasekharan, who spoke about React Forget at React India. And see, this is what excites me about React, is that they are constantly working on improving the technology. They are constantly coming up with so many different ideas to, just benefit front-end development by itself. And that's why I think React has, I think, stayed the test of time. So that is what I really like about it. I think it's really great feature. I'm looking forward for its release. And yeah, I think it will be a really interesting feature to, use. Then is in React website, it's asked to switch bundles like Vite and framework for Next.js. Mm, in React website, it is asked to switch bundles like Vite and framework. I'm not sure where in the React website they've mentioned to use this, but I think what you mean is for some features, that is React 18 features, they are there are no, they are have not exposed APIs yet in React itself. So one such is, I think, your what is that? Streaming HTML and selective hydration suspense related changes. I think you can use them out of the box in Next.js, Relay and stuff, but there are still not APIs that are exposed within React itself for those changes. And that's why I think at some places they might have recommended us to use some frameworks like Next.js, Relay and stuff. But otherwise, see, Next.js has its own users, Remix has its own users. So it does not depend on which framework is better. it's important to understand if certain frameworks are built on top of React, why they are built on top of React. Next.js is built for, if you want to have a server-side rendered website. So it employ some optimization on tops of React for helping server-side rendered applications. So if you want to build an application that has to take advantages of, server-side rendering, it's recommended that you go with Next.js. But even to use those frameworks, you have to be, well equipped with React as a framework. So I wouldn't say any framework is better than the other just by the technology itself. It's just that the use cases for which the frameworks were created are different and cater to different types of applications. So it's important before you start any project in any application, you understand what is actually that you want to build and which will be the best framework for that, depending on the features that they provide you. Next, in stock exchange website, concurrent rendering is being used. If yes, then what are they were using before React 18? See, stock exchange. So again, stock exchange website, any fintech websites, it's not a front end heavy thing. Actually, it is front end heavy, but also they have a lot of technology or optimizations from the back end. There are things like long polling, short polling, server side events, all of this that are used to extract real-time data at the front end. But it's not like they are using concurrent rendering, and before React 18, like these features were not there. Concurrent rendering is, I think, misunderstood. It's not that we are delivering some features or some updates concurrently. No. The concurrency is a thing. If you read concurrency in Java, it's actually you're able to run threads parallelly, but because Java is again multi-threaded. But JavaScript is not multi-threaded, it is single-threaded. So concurrency in JavaScript is not parallel tasks that are running. It's actually tasks that are scheduled on a single thread. So if I think some Java developers may say it's pseudo concurrency, but yeah, that's how it works. And when it comes to different applications, again, as I said, there are different, concepts like long polling, short polling. I think all these tracking websites, like Swiggy, Zomato, and all these, wherein you track how far your delivery boy has traveled and all that. They use something called long polling and short polling of APIs to get the real-time updates. Then there are server-side events. Server-side events, you can use that also. So just I would suggest you to go about their website. If any application interests you and they have a technical blog by their engineering team, go by their website and see how certain things are done. That will help you actually understand the concepts also, and gain, if you don't know already, certain concepts that are being employed, and which is the case with everyone actually. I also learned these concepts like some time back only, because I was reading from some place or discussing with people, and they told me about the existence of certain features and things, concepts also. So just read and see how things are done, and that will help you more. I think, yeah, Vishaka, I'm good.
Sure. So Kirti, I think with that, we'll come to the conclusion of the webinar. Thank you for all your insights, and thank you for taking up all our questions. And thank you for your time as well. Thank you to all our listeners for joining us. Hope this webinar was informative for you. Would request you to please check out our community. To grow your network, get mentored, and learn with some amazing developers. Hope to see you at the server soon. Thank you, guys. And with this, we'll be coming up with a few more webinars, and we keep coming up with more webinars. So do follow us on LinkedIn and stay up to date with all our upcoming learning and upskilling sessions. Thank you, Kirti. Let's end the session.